Hello students, in today's class we are going to solve one more problem on formation of Y bus using singular transformation method. This is the problem given: obtain Y bus using singular transformation method for the system having following data. Take fourth bus as a reference bus. This is asked in January 2020 VTU question paper. So this is the given data. From this we have to form the graph. How do we form the graph? First we have to identify how many buses are there. From this given data, it is we can see here only up to fourth node we have, or fourth bus we have. Okay, just to mark the nodes. Okay, fourth bus is a reference bus, so let it be downwards here. Okay, and first bus. Okay, first bus, second bus, third bus. Okay, check, do we have connection from 1 to 2? Okay, see, we have connection from 1 to 2. The element 1 is connected from 1 to 2. So draw the line segment from 1 to 2. Next, second element is connected between 2 to 3. Okay, and third element is connected between 3 to 4. And fourth element is connected between 1 to 4. Okay, fourth element is connected between 1 to 4. Fifth element is connected between 2 to 4. Okay, you can assume the directions downwards or upwards, here left side or right side according to your wish. Finally you are going to get the same answer. See, this is the oriented graph we have. From this oriented graph, okay, we can get the element node incidence matrix A cap. From A cap we can derive A. Okay, we can obtain A, that is bus incidence matrix. Finally, we are going to form the Y bus using singular transformation method using this formula, A transpose Y matrix into A. So we have to get A cap first. So how do we get A cap? So look at the oriented graph here. In oriented graph, the first element is incident to node 1 and node 2. Okay, incident to node 1 and node 2. It is not incident to node 3 or not incident to node 4. So take it as 0. Before that, what we have to do, column has a number of elements and row has number of nodes. Just note it down as it is: 1, 2, 3, 4, 5 and 1, 2, 3, 4 reference node. So I have indicated reference node here. Okay, numbered reference node here. Next, take second element 2 to 3. It is incident to 2 as well as 3. 2 to 3, and it is not incident to 4, it is not incident to 1. Okay, take it as 0, but which one is positive and which one is negative we have to see. See, the 2 is leaving 2, okay, and going towards 3. So leaving, okay, and entering, okay, entering 3. Okay, going towards 3, so it has to be -1. Next, third element is between 3 and 4, okay, 3 and 4, and it is not incident to 1, not incident to 2, take it as 0, and it has to be -1. Why? Because according to my diagram, the third element leaving 3, okay, leaving 3, so it has to be +1. And going towards 4, so it has to be -1. Fourth element, it is between 1 and 4. 1 and 4, it is not incident to 2 or not incident to 3, so make it 0. So why it has to be 0, -1? Because it is going towards 4, leaving 1. Leaving 1, so it has to be positive, and going towards 4, so it has to be -1. Fifth element, it is connected between 2 and 4. 2 and 4, rest 2 elements should be 0, and it is leaving 2, okay, moving away from 2 and going towards 4, so it has to be minus 1. Okay, understood? Now we have to get matrix A, okay, from matrix A cap. See, we have to delete column corresponding to reference node. Okay, column corresponding to reference node we have to delete, then we will get matrix A. Okay, matrix A we got, what we have to get is matrix Y. Okay, so in order to get matrix Y, just look at the data given. Admittance it is given, admittance value directly it is given in per unit. So take it directly. So since it is a self admittance, only diagonal elements will be there. This is a diagonal matrix. Okay, 2 0 0 0 0 0 1.5 0 0 0 0 0 3 0 0 0 0 0 2.5 0 0 0 0 0 4. Okay, so we have now matrix A as well as matrix Y. We have to find the matrix Y bus. Y bus is equal to A transpose Y A. Okay, A transpose Y A, A transpose, so A transpose can be written like this. A transpose is equal to, here the row of A will become column, column of A becomes row. So this is the first column, this becomes first row 1 0 0 1 0, second column becomes second row 0 0 1 0 minus 1 1 0 0. Here Y bus is A transpose Y A, and A transpose which is calculated 1 0 0 1 0 minus 1 1 0 0 1 0 minus 1 1 0 0, and matrix Y which is found from the network, which is 2 0 0 0 0 0 1.5 0 0 0 0 0 3 0 0 0 0 0 2.5 0 and 0 0 0 0 4, 5 cross 5 matrix. Next, matrix A which is plus 1 minus 1 0 0 1 minus 1 0 0 1 1 0 0 0 1 0. Okay, now on multiplying first row with first column, we get 1 into 2, it is 2, and remaining all are 0. 2 will be added with 0, so it becomes 2. Okay, first row with second column, okay, it is 0. First row with third column, it is 0. First row with fourth column, okay, here it is fourth element, even it is fourth element. Fourth element is multiplied with the fourth element and it is added with the zeros, so it would be 2.5. First row and fifth column, it is 0. Okay, and second row first column, it is minus 2. Second row second column, it is 1.5. Second row third column, it is 0. Second row fourth column, on multiplying it would be 0. Second row fifth column, on multiplying it would be plus 4. Similarly, third row and first column, okay, first row multiplying with first column, it would be 0. First row on multiplying with second column, it would be minus 1.5. Third row on multiplying with third column, it would be plus 3. Third row on multiplying with fourth column, it would be 0. Third row on multiplying with fifth column, it would be 0. Okay, this is the matrix, resulting matrix, and we have left with matrix A. So 1 minus 1, 0, 0 1 minus 1, 0 0 1, okay, and 1 0 0, 0 1 0. Now take first row and first column. Okay, here first element is 2. Okay, here first element is there, it is a number, non-zero number. Okay, here fourth element is 2.5, here fourth element is 1. So on multiplying, we get 4.5 first row with second column. Okay, it is minus 2. Okay, minus 2 it becomes. First row with third column, it is 0. Okay, second row with first column, okay, minus 2 into 1, it is minus 2 plus 0, and it would be minus 2. Second row with second column, okay, minus 2 into minus 1, it is plus 2. 1.5 into 1, it is 1.5. 4 into 1, it is 4. So 4 plus 2, 6. 6 plus 1.5, 7.5. And second row third column, it is minus 1.5. Okay, third row first column, it is 0. Okay, third row second column, it is minus 1.5. Third row third column, it is minus 1.5 into minus 1, it is plus 1.5. 3 into 1, it is 3. So totally 4.5. This is matrix Y bus. Thank you.